Let's take a look at the polygon resource sheet. If we want to access it, as you know, we just click on the template that we want to use, and it takes you to the template with some images and with the purpose activities that you can do, some suggested activities that you can do. And of course, again, if you want to print, you just hit the print button. The PDF comes up, print it and copy it, give it to your students, and then you can ask some of the questions that we're talking about in the template. What the purpose of this template is basically is for kids to be able to extend and describe patterns about polygons. So the first thing you do is you have kids take a look at the idea that they have to observe all of the patterns in the polygons, and they have to then think about what pattern that they see. So typically what happens is you give them a couple minutes, have them write the pattern that they see on a communicator, have them hold the communicator up, and then you can call on kids to talk about the patterns that they found. So inevitably the patterns that kids find with this are the sides. So they talk about the sides, and they talk about the pattern goes basically where you have a three-sided figure, a four-sided figure, a five-sided figure, a six-sided figure, an eight-sided figure, a 3, a 4, a 5, a 6, and an 8, and then it repeats itself: 3, 4, 5, 6, 8, and then 3. So that's one pattern. You could then extend your thinking or your questioning to, well, what is the name of a three-sided figure, or what is the name of an eight-sided figure, or what's the name of a five-sided figure? Instead of naming them as 3, 4, 5, 6, and 8, let's name them as triangle, quadrilateral, pentagon, hexagon, and octagon. So that's one pattern kids will come up with. You want to ask the question, are there any other patterns that kids have seen? And there are, of course, many other patterns. So another kid might see this as the diagonal. They might see that all of the diagonals from left to right have exactly the same shape. Those are all triangles. These are all quadrilaterals. Then we can go back to these being all pentagons, and we could take this one and so forth. These are all octagons. Now, that's another pattern that they see. Let's take another one that they might see, and a lot of kids will start to see the difference between the first 5 polygons and the next 5 polygons. So again, if I highlight some of these, you can see that these particular polygons look a lot different than those. Even though this is the triangle and that's a triangle, and this is a quadrilateral and that's a quadrilateral, they look so different. So if you've covered regular polygons, hopefully they say that these first 5 appear to be regular polygons and the next 5 appear not to be. So this is a regular triangle, this is a square, a regular pentagon, a hexagon, a regular hexagon, and a regular octagon. Now, if you want to convince them that it is, again, they only appear because they're not really marked, but this is very effective. Have them highlight the triangle, and I'm just going to drag over the triangle. So have the kids highlight the triangle, have them put the communicator on top of the template, and have them highlight the triangle. Now what you can do is have them turn the communicator. They're going to be turning the communicator. I'm just going to be rotating the shape, and I'm going to have to slide it back down. But the point is, when you rotate it with the communicator, you don't have to slide it, and they can see what has happened is that the triangle appears to be on top of itself and shows that that angle is equal. You could also just bring a point over here and put it in the vertex like this. You could then group this as one grouping of shapes, and then you could move it and you could really count. So if I move this over, and again, you wouldn't have to slide it over, but the point is, there's one rotation and they're equal. Move it again and it's a different one and different spot, but they're still on top of each other and the angles are equal. The other thing you could do is, instead of using this, you could take this, and we can also show that the angles are equal by simply taking some line segments, take a line segment and I draw that line segment like that, basically on top of the triangle, and I take another one and put it over here, what I can do is, again, I can group those. So let's just take this and group these two. It won't be exact because my figure isn't quite exact, but you get the idea of what we can do. Group that, and then we can turn it, and they can slide it down. Again, they're doing this on the communicator, and they can see that the angles indeed are equal. So I won't do every one here, but on the shapes we gave you over here, you could do exactly the same thing with any other shape. So you have this shape over here, and you could take your point and you can put it up there, or if you don't want to have the point, you can just get that off of there and you can just rotate it. And when you rotate it, you can count the number of times it goes around, but you can see that all the angles are equal and all the sides are equal. Again, you could highlight just the angle or the sides and do exactly the same thing. Okay, so one thing that you don't want to miss as part of this, which is really cool, is that what I do with the kids is once they see these three basic patterns, what you want them to do now is the next is extend their thinking. So you want to ask the question, questions like what shape would be in square number 20 if we had a square number 20? Well, other kids will have seen patterns where the equilateral triangle is going to be what? If you add 10 to 1, it's in the 11th one. If you add 10 to 2, you get a square. 10 to 3, you get 13, and it's the same shape. In fact, you could also take the opportunity to talk about congruency, because what you can do is you can highlight. Let's take the pentagon, and let's just slide that pentagon down. So again, you're going to have them take that, and you're going to have them highlight that pentagon, and then move the communicator down. I'm just moving the shape. They would move the whole communicator down to number 13, and then you can get the idea of what a congruent figure is. So every 10, if you add 10 to each figure, you're going to end up with a congruent figure. If you add 10 to 6, you get 16, which is the next one. So once we get that out of the way, we can then talk to kids about moving on to extending the pattern like we did a couple of minutes. What would be in number 20? Well, if this is number 16, which is down here, this would be 17, this would be 18, this would be 19, this would be 20. So the irregular octagon is in number 20. You could have them write that shape on their communicator, the name, and then you can hold it up to see if they can see how the kids are doing. You can monitor and adjust your lesson from there. You can ask what shape is going to be in number 47. How often do they change? Do they change every 5? So basically you get the idea of patterning and describing patterns and so forth. Again, when you want to implement this without this voiceover, all you have to do is go back to the original page, the front page, click on the template that you want. Instead of listening to me, what you're going to do is you're going to just go right to implement, and you can implement the activities that we just did, or you can create new activities of your own. Click return, and you go back to our home sheet.